And the kite manufacturer only makes quadrilateral kites, and they're only convex quadrilateral kites. This company is getting really tired of making a different kite, figuring out how to make a kite of any shape or any size that fits those categories as the orders come in. And so instead of figuring out, like if an order comes in for a square kite, instead of having to figure it out right then, they need directions, specific directions, on how to make a square kite. Two long ones and one short one. And then you've got this brad, and the brad holds them together. So what I'm going to do is I'm going to model for you how you might put these together to make a quadrilateral. So I'm going to do just something like this. Okay. And what you will do on your paper is something like this. So I'm going to mark the last hole, and those points will serve as the vertices of the quadrilateral. And then I got to figure out where were those sticks. So I'm going to put a dotted line there. Okay, so those represent the two sticks. And then what kind of a figure do you think this is? Can you visualize it? It is a quadrilateral. Does it have any special characteristics? Kind of a generic quadrilateral? See, play around with this for about 5 minutes.
And you get a parallelogram anywhere you go.
Oh.
Anywhere.
Cool.
Yeah, it looks like it's 1, 2, 3. It's like 8.5 dots. They're all in here.
Right.
Yeah, so I guess it's a rhombus.
The thing is kind of like when you do it, you have the diagonal, so you kind of make like a triangle.
Yeah.
So I think that has something to do with it.
That has.
Not quite sure. Probably does.
We're supposed to show like which diagonals make the same shape, but like this, it could make a rhombus or parallelogram, or if you like, yeah, and like these could make a rectangle or a square. It all depends on the angle of the plane, so we can't just use that. Sort of like impossible to just use these. And anyways, they're not like these like things are off. They're like some are up, some are down, and so it's not conclusive evidence either.
Yeah, it's not completely accurate.
Yeah, exactly.
So I want to remind you about.
Is that like to make a trapezium, you can have like 2, and this is 3, and this is 5, and this is 6, so they're all different.
But if they're equal, then it'll come out with equal sides.
Yeah, but since they're all different, then you can make them.
Like, to make a square, it's like in the
I tried to do that, but it's hard to, because don't the angles need to be congruent also, like right here? You need to make it so that these angles are congruent.
Well, yeah, but
if like,
because like these kids spin around.
All of your tinkering work.
Yeah.
Unless they have to place it like a 90-degree angle, that's a square.
And for like other stuff, for like rectangles also. How do we do a rectangle?
Is this a rectangle?
Yeah,
this is a rectangle.
Yeah.
Anything could be pretty much
Oh,
a rectangle.
I think.
Oh yeah.
Parallel
and
like,
equal.
If each thing is equal, then it's a rectangle. But then,
So like
if you make it at a 90-degree angle, then it's a square. But if otherwise, it's a rectangle.
And mine's a rectangle.
Oh, that's cool.
Yeah.
Here's a
Anyway, it's a
trapezoid. It looks like
But these have to.
It looks like a little bit, because these are parallel.
If you guys need help with right angles, I can help you.
Two congruent sticks.
Okay.
Yeah, read to her and then
Okay. So you need two congruent
And then
sticks
we'll explain that.
intersecting at their own midpoints, making perpendicular angles. They're perpendicular to each other.
Yeah.
Okay. Making right angles. Okay.
Right angles. And then
That's it?
Yeah, these all.
And you're saying that this will guarantee a square.
Yeah.
Prove it.
Yeah,
Okay.
if these are the same length and
Okay, prove it.
So now,
okay, so see you have sorry. You can do it.
That's a good idea, Roy. You did get cut off. He's right. Thank you, Brent.
Okay, you can do it.
okay, so once you connect all, okay, so pretend I shrunk the sticks down and I made this.
Okay.
So I connected all the diagonals,
And what's your goal here?
and my goal is to prove that all of these are congruent, and it makes a 90-degree angle, so it'll be a square.
The whole, like when it sits like this.
It's got to be less than 90. I'll let you know. Right?
Yeah, but would it make like like since it's like this, would these two be equal or would these two be equal? Do we know anything like that? Because I bet we can prove it.
But we don't know that. We haven't proved that.
So if this, so we know that these two angles have to be equal. So like angle B, angle A, and B. Because these two are equal and these are linear pair of angles.
We figure that out. Like
So
that whole.
no matter what, even if it's linear or if it's out of 360, they have to be equal angle A and B. So how do we prove that they're parallel is by proving this angle is equal, right? This angle is equal to this angle, but we don't. It can't necessarily extend infinitely down. So we have to make sure that it's like, and this has to be like out of 90 or like out of something. Because we don't know for sure if it's going to be out of 90 or could even be at like 80, you know.
I think we're taking the wrong approach, though.
Or no, how about like, you know how like the trapezoid, its interior angle is measured to 360. So if we minus these, yeah, that would work. If we minus since we minus, if we minus these, and then these would all have to be equal, so like 360, okay? See if this was like 60, and this is 60, right?
But you're not going to know the angle.
Yeah, we will. Watch.
Yeah.